Okay, you pre-calcers, let's look at this Unit 5 practice test. First problem's kind of a doozy. It's an inequality, but you can see we've got x in the denominator, which means the first thing we need to think about is what can't x equal? We know that x cannot equal a 3, so we're going to put a 3 right here with an open circle. Can't equal a 2, so we're going to put that right here. Now, when we're doing these problems, it's later on when we plug values in, we'd like it to be greater than or equal to 0. So I'm going to subtract this value from this side, and then I'm going to subtract it from the other side. Now I'm going to rewrite this as 5 over x minus 3 minus 4 over x minus 2 is greater than or equal to 0. That'll make our lives a little easier a little later. Now I'm going to take care of this add op, just so I don't forget it's a subtraction problem. Easy to do, but that's one way you take care of it. So now we're actually going to solve this thing and find out where this actually happens. So we're going to go ahead and multiply this by the least common multiple of our denominators, which would be x minus 3 and x minus 2. Now if this hits this, my x minus 3's get absorbed, so that would disappear. 5 distributed through there would give me 5x minus 10. Now I'm going to distribute this through here. The x minus 2's would cancel, and I'd end up with negative 4 times this, so that'd be minus 4x plus 12. Now when this hits the 0, nothing happens, which is good. So 5x minus 4x is x, negative 10 plus 12 is 2, and we're going to find out that x is greater than or equal to negative 2. So if we take this and we go to negative 2, we know, if we read this, x is greater than or equal to negative 2, we know at least that negative 2 will work. Now let's investigate this, because we've got 1, 2, 3, 4 spaces to investigate. So how do we do that? Well, we're going to take a look at a value less than negative 2, which would be negative 3. Plug this. I'm going to go back to this. I shouldn't have crossed those out, but this is x minus 3, and this is x minus 2, just in case you wonder. So I'm going to plug in negative 3 for my x values and just see what happens, see if it's true or false. So 5 over negative 3 minus 3 is negative 6, plus negative 4 over negative 3 minus 2 is negative 5. So that's negative 5 6 plus 4 fifths. Now, 5 6 is like 0.83. This is 0.8. So I know this is more negatives than positives, so it is not greater than or equal to 0. You could also find common denominators, but regardless, there's more negatives than positives, so this is a fail. So now we're going to plug in this space. Easiest thing to plug in is a 0. So 5 over 0 minus 3 would be negative 5 thirds. I just brought the negative up. 0 minus 2 is negative 2, so that's negative 4 over negative 2, which would be 2. As you can see, this space passes the test because 2 minus 1 2/3 is positive, so this passes the test. We'll get back to that in a minute. Let's plug in 2.5. So 2.5 minus 3, I'm going to write it like this. It's negative 0.5, but I'm going to write it as negative 1/2 because my brain will handle it better. And then 2.5 minus 2 is 0.5, but I'm going to write this as a positive 1/2 because I know if I divide by a fraction, I multiply by the reciprocal, so that'd be negative 10 plus negative 8. Is that greater than or equal to 0? No. So this blue space failed. Now let's type something in greater than 3. Let's try a 4. So I'm going to type in a 4 here. So 4 minus 3 is 1. 5 over 1 is 5. 4 minus 2 is 2. Negative 4 over 2 is negative 2. And is that greater than or equal to 0? Yes. So this space passes as well. So what's my final answer? I got to explain this area. So x greater than or equal to negative 2, but less than 2. And then x is greater than 3. There's my answer. Not every problem is going to take this long. But number 2 is kind of tricky as well. So it says rewrite 8 to the 3x minus 2 power in this form. So we've got to somehow get a constant pulled out here and then a constant raised to the x power out of this. Well, if we remember our rules, x squared times x cubed equals x to the 5th, we're going to take advantage of that rule by saying, aha, this is the same thing as 8 to the 3x times 8 to the negative 2 power. Now remember, we need something out in front, and that's going to come from here. Remember, 2 times 7 equals 7 times 2, so we can rearrange multiplication problems. This is the same thing as 1 over 64, or 1 over 8 squared. I'm going to pull that out in the front, and I'm going to get 1 over 64, there's my a, times 8 to the 3x power. Now, we still have a problem because we've got this x. We strictly need that x, so somehow we got to get that 3 out of there. So if we do a little math trickeration based off this, if we have like 2 squared cubed, that's the same thing as 2 to the 2 times 3 power. You can just kind of cover that up with your finger and just kind of bite off a chunk. So we're going to take that right there, and we're going to look at that 8 cubed. 8 times 8 is 64. 64 times 8 is 512. So that would be the same thing as 1 over 64 times 512 to the x power. And then we have arrived at our goal. All right, write as a single log. Well, the first thing we're going to do is remember the 2 shall become 1. Addition means multiplication. So we're going to multiply 24 times 3 and then write it as a single log. Don't forget this little base. So 3 times 24 is 72 minus log base 3, 9. If these bases aren't the same, you can't do anything. So so now we got to do the same thing. The 2 shall become 1. Subtraction means division. We divide 72 by 9. So technically it's 72 over 9, and that reduces to this. And it just says write as a single log. It doesn't say simplify or solve, so we can just stop right there. You just got to pay attention to the instructions. Now this says solve. Now notice we've got common bases. We've got a 2 here and a 2 here, which means whatever's in this space has to equal whatever's in that space. So we get 2x plus 7 equals x squared. Now I'm going to subtract 2x, subtract 7, subtract 2x, subtract 7. And so I get 0 equals x squared minus 2x minus 7. I'm looking at this. I wish it could factor, but it doesn't. Okay, so I got the quadratic formula ready because it doesn't factor. So take the opposite of b. So that's 2 plus or minus the square root of b squared, which is 4, minus 4 times a times c, all over 2a, which would just be 2. Now these two negatives make a positive. So that'd be 7 times 1 times 4 is 28, plus 4 is 32. So I'm going to do my work up here. 2 plus or minus the square root of 32. Now that's the square root of 16 and the square root of 2, all over 2, which is 2 plus or minus 4 square root of 2, all over 2. Now notice the 2 will go into both of those. Whoops. Again, I went off the screen, but there's my work. So I went from here to here to here to here. And now the 2's go in here, so I get 1 plus or minus 2 square root of 2. That would be my answer for x. Okay, now this says solve. Let's take a look at this one. So first of all, we look at this and we say, hey, wait a minute, the 2 shall become 1. That also applies to natural logarithms by division. So I'm going to write this as the natural log of x plus 2 over 3x plus 5 equals 6. Now this gets a little wonky, you just have to follow it. Every one of these problems is slightly different. Because it's a natural log, there's an invisible e here. So now I'm going to go e to the 6th power equals whatever's in my answer spot. So I get x plus 2 over 3x plus 5. Okay, so don't forget what we're trying to find. We're trying to find x. So when we get to here, we're like, wait a minute, we got to multiply by 3x plus 5. So those would cancel. And then this would be times 3x plus 5. Now this is going to look awfully strange, but just hang tough. So we distribute this through. We'd get 3 e to the 6th x plus 5 e to the 6th, that's an e, equals x plus 2. Again, what are we trying to solve for? Trying to find x. So I'm going to get my x's on this side. I'm going to subtract x. These are not like terms. So 3e to the 6th x minus x. I'm going to subtract 5e to the 6th. Subtract 5e to the 6th. These cancel. So I would get 2 minus 5e to the 6th. So I'm going to factor an x out here. So I'd be left with x times 3e to the 6th minus 1 equals 2 minus 5e to the 6th. Am I still on the page? Yes. Now I got to divide by this. 3e to the 6th minus 1, gone. Divide by 3e to the 6th minus 1. You can see x equals that. Pretty tough. A lot to keep track of there. Number 6 takes us back to the common basis happy places. I see a 5, 125. I can see I'm going to change that 125 to 5 cubed and bring it up. So remember, x to the negative 2 power is 1 over x squared. So if I put a negative exponent where it isn't, it becomes positive. But if I put a positive exponent where it isn't, it becomes negative. And I'm going to do that right here. So this stays 5 to the 2x minus 1. This comes up, and I get 5 to the negative 3rd power to the negative 3x. And I say, hey, wait a minute, power to power I multiply. So this is 5 to the 2x minus 1 equals 5 to the 9x. Now once you get to this place, these disappear. This has to equal this. So 2x minus 1 equals 9x. I'm going to subtract 2x, subtract 2x. I'm going to spin it around. 7x equals negative 1. Divide by 7, divide by 7. I can see x equals negative 1/7. There you have it. Number 7, solve. Well, instinctively, just divide both sides by 4. So I'd get e cubed equals 8. Give me a second here. Okay, what caught my eye about this little bugger is I forgot to put in a little x right here. So there was nothing to solve for, because remember, e is not a variable, it's 2.71. So there would be a little x right there. I'll go back and fix that in a second. But okay, so what do we do now? Well, common basis happy places, which just occurred here, is not happening here. But because that's an e, we're going to slap a natural log on this side, slap a natural log on that side, which allows me to bring this in the front according to my laws of logarithms. And don't forget, natural log of e equals 1. Why? Because there's an invisible e here. E to the 1st power is e. So, but then we can bring this in front. So we get 3x equals, now we're going to take out our handy dandy calculator, and we're going to take the natural log. It's that button right there, of 8, and that's 2.08, we'll call it. And then we got to divide both sides by 3. So divided by 3, and we get 0.69. And that'll do it for this video. You're going to have to go to part 2.